is directly proportional to force acting on it. So greater the force, greater will be the change in momentum. Okay. Uh, yes. F equal to ma or F net equal to ma is the formula for force that we get. Unit of force is Newton, and it is a vector quantity. Then I was telling you, what do you mean by net force or resultant force? If two or more forces act on a body, ఎవరో మ్యూట్ చేసుకోవాలి. If two or more forces act on a body at a given time, then the motion or acceleration of the body will be decided by not either of the forces, but by the resultant of all the forces. And we took some examples also: forces acting in same direction, in opposite direction, same forces in opposite direction, different forces in same direction, forces at right angle, 60 degree, 30 degree, all these things. So resultant or net force will give you the direction of motion or the acceleration of the body. Okay. After this, next thing is okay, we have Newton's third law. We'll see that Newton's third law. Then we'll go to the other things. Newton's third law. Very simple, very easy, one-line statement. Third law, or this is also called law of action-reaction. Law of action-reaction. So very simple, easy, and a famous statement for Newton's third law. What does it say?
Every action has its reaction.
Every action has
Equal and opposite reaction.
an equal and opposite reaction. Every action has equal and opposite reaction. Okay. To understand this in detail, first of all, what do you mean by action and what do you mean by reaction? Action and reaction. Reaction is not your reaction of chemistry, and action is not action of your movies, light camera action. It's not that action. Here, action and reaction both mean forces. Action is a force and reaction is also a force. Or in other words, for every force, there will be an equal and opposite force existing in nature. Equal and opposite force exists in nature for every force that you find. Okay. And if you take some examples for this action reaction, if you hit a ball, suppose a ball of mass m moving with velocity u hits the wall, what is happening here? If you understand in detail, if you observe clearly, the moment the ball hits the wall, its velocity is becoming zero momentarily. That means the ball is stopping. Then it changes its direction, bounces back. Let us say with same velocity, but now in this direction. When the velocity stopped, then again after that the ball bounced back. That means the ball is again getting velocity. The ball is again, let us say it was going at 10 meters per second. Here, when it hits the wall, its velocity becomes zero because it stops, then bounces back. Let us say it again bounces back with the same velocity, 10 meters per second. Now, after it became zero, how is the ball able to get that velocity? Here, you might have thrown the ball with your hand. You might have thrown the ball. So, you are giving velocity to the ball. But here, how is the ball gaining velocity? If ball is gaining
The wall,
velocity
sir.
0 to 10 meters per second, that means there is acceleration. There is acceleration, v minus u by t. This takes place in certain time, 0.1 second, 0.01 second, small interval of time. So in short interval of time, velocity of the ball is changing from 0 to 10. That means there is acceleration in the ball. If there is acceleration, definitely force must be there. Without force, you cannot get acceleration. F equal to m. So who who is applying this force? The wall is applying this force. The force with which the ball hits the wall, you can call it as action. And the force which is applied on the ball by the wall, you can call it as a reaction. So ball is giving action on the wall, and the wall is giving reaction on the ball, because of which it is bouncing back. And if you take firing of a rocket, when a rocket is fired, a heavy volume of gases, large quantity of gases, they will be ejected out of the rocket in downward direction. This you can call it as action, because all the gas molecules, they will be coming out with very high velocities, and there are millions of such molecules. So these will be exerting force, or this will be exerting force in the downward direction, action. And as a reaction, the rocket goes up. Action, reaction. These are some simple examples of action, reaction. And there are certain important points which you should understand regarding action, reaction. One point is, okay, see, let us take a example. Suppose there is, you are going in a car and your car has breakdown. Let us say fuel is over, petrol is over. Then the driver, say your father, someone, your parent, asks you to get down and push the car. Asks you to get down and push the car. Okay. So you are here and you are pushing the car. You are pushing the car means you are applying force on the car. Force by man on car. Force by man on car. Okay. Then according to Newton's third law, car will also apply force on you, just like this ball and wall. If ball is applying force on the wall, wall is also applying force on the ball. So here you are applying force on the car to push it. So the car should also apply force on you. Force by car on man. Force by car on man. And how will be these two forces? They will be equal and opposite from Newton's third law. Force by man on car is equal to force by car on man, but opposite, minus. You are applying 100 Newton force on the car. Car will also apply 100 Newton force on you. If you apply 500 Newton force on the car will apply 500 Newton force on you. Action and reaction are equal and opposite.
Sir,
Listen completely. So let us say you are applying 100 Newton force on the car, and the car is applying 100 Newton force on you. Now, do these two forces get cancelled? Force by man on car and force by
No,
car.
sir.
Yes, sir.
No, sir.
If these two forces are getting cancelled, means resultant force is zero.
Yes, sir.
Resultant force is zero. If resultant force is zero,
There is no force.
the car will not move, sir.
car cannot move if there is no force. But practically, we see that the car moves if you push it. What is happening here?
Sir, the two forces acting on two different bodies, sir. So they
Oh.
did not cancel, sir.
Yes. two forces will cancel each other only when they act on the same body. If this is the body and I am applying a 100 Newton force here and another 100 Newton force here, these two forces are equal and opposite and acting on the same body, this body. So they'll get cancelled and the acceleration of this body will be zero. But here the forces are acting on two different bodies. Force by man on the car is acting on the car. Force by car on the man is acting on the man. As they are not acting on the same body, they cannot get cancelled. Action, reaction do not get cancelled. If they are not getting cancelled, there is resultant force. There is a resultant force. If there is resultant force, there will be acceleration. Because of that resultant force, the car moves. So point here is action and reaction always act on two different bodies. Hence, they do not cancel each other. In the example of that ball and wall also, action was on the wall, reaction was on the ball. In rocket also, action is on the ground, reaction is on the rocket. So they always act in two different bodies and they don't get cancelled. Next, another point is from this we get one important conclusion. Forces always exist in pairs.
Sir, in the first one, what did you write, sir, after two different bodies?
Hence, they do not cancel each other.
Okay.
So forces always exist in pairs. A single isolated force is not possible.
Yes, sir.
And also, action and reaction are, you can say, instant or spontaneous. Spontaneous. That means action and reaction happen at the same time. There is no time lag or there is no time delay between action and reaction. It's not like action takes place now and reaction will come 1 second later or 1 hour later or 1 day later. It does not happen. The moment there is action, immediately along with action, there will be reaction. So they both take place simultaneously. Action, reaction are simultaneous. Simultaneous. Okay. This is Newton's third law of action reaction. Right. Three laws. First law says what is inertia, and from that we get the definition of force. Second law says what is how much is force. It is based on momentum, F equal to ma, or force is directly proportional to rate of change of momentum. Third law tells us about the nature of force. Forces exist in pairs, and for every action there will be an equal and opposite reaction. Okay. Next. After we know the three laws, one term is there, an important term, impulse. Impulse. What is this? We have defined momentum as a product of mass and velocity. Body of mass m moving with velocity v will have momentum mv. Okay. Impulse is defined as it is the product of
Force and time.
force and time of action of or time of application of force. That means impulse is force multiplied by time. Force multiplied by time. Impulse is denoted, the standard symbol that we use for impulse is I. In some textbooks, J is also used, but commonly I is used to represent impulse. Is equal to force into time. Force into time. Okay. So this is a new term, impulse. Definition is product of force and time, and formula is I equal to Ft. Then what should be the unit of measuring impulse? Impulse is measured in the
10
unit
seconds, Newton seconds.
Newton second, because force is measured in Newton, time is measured in second. So SI unit is Newton second. And this is also a vector quantity. Impulse is a vector quantity. Okay. So what does this impulse tell us? What information does it give? Impulse tells us about the effect of force. It gives us the effect of force. What do you mean by this? Same force acting on the same body, but for different times, produces different effects. Like, for example, let us say there is a wall, and in this wall, I want to drive a nail which is like this, a sharp nail. Okay. I want to drive this nail in the wall. I use a hammer. Okay. I use a hammer like this. And using this hammer, let us say I am not hitting the nail, but I am pushing the nail with the hammer. I am not hitting it. I am pushing the hammer against the nail. Let us say the force that I am applying here is some 100 Newton. I am pushing the nail within force of 100 Newton. Will the nail go into the wall?
No, sir.
No. Even if you try it from morning till evening, the nail will not be driven into the wall. In the second situation, same nail, same wall, same hammer, but this time I am going to hit the nail with hammer. I am going to hit it with the same force, 100 Newton. I am not increasing the force. Same force, 100 Newton. Will the nail go
Yes,
into the wall?
sir.
Yes, sir.
What is the difference here? The difference is in the time of application of force. Difference is in the time of application of force. When you are pushing the nail with the hammer, you are applying 100 Newton force for a very long time. For a very long time. Let us say 1 second, 2 seconds, 10 seconds. But when you hit the nail with hammer and nail will be in contact for a very, very small time. let us say some 0.01 second. Here it is 1 second, which is 100 times larger. Okay, so when the time of application of force is changing, the effect is changing, and we represent this effect with impulse. Okay, if impulse is the same impulse, it can be written in one more way. Say impulse is force into time. Okay, we know force is ma into time. Okay, and we know acceleration is v minus u by t into t cancel. That means m into v minus u. That means mv minus me. mv is momentum. Which momentum? Final moment. mu is also momentum. Which momentum? Initial moment. So impulse is also equal to change in momentum. Force into time is one formula for impulse. Change in momentum is another formula to measure impulse. Force into time, change in momentum. And we find a lot of applications, lot of situations where we come across this impulse in our daily lives. For example, this catching a cricket ball. Cricketer pulls his hands back while catching. Every one of you might have done this. We do this involuntarily, without our knowledge. We pull our hands back while catching the ball. Why is this? What happens if you don't pull your hands back?
The
If you don't
force
pull your hands
will
back,
be more,
let us
sir.
say
The force acting.
you are playing with a cork ball. So if you don't pull your hands back while catching the ball, you will feel pain.
Yes, sir.
Why are you getting this pain? Because the ball is coming with certain momentum. It has mass. It is coming with some velocity. And let us say you are catching it like this. It comes and hits your hand. If you don't pull your hands back, the time in which the ball stops will be very less. Time will be very less.
So the
Impulse
force will be
is
very more, sir.
force into time. That means force is impulse by time. So if time is less, force will be more. If you stop the ball very quickly, force on your hands will be more. If you pull your hand back, the time of contact or the time of stopping of the ball will increase. If time increases, force decreases. So you will not feel more pain. That's why we pull our hands back while catching the ball. Next is shock absorbers are used in vehicles, are used in automobiles. To reduce impulse. What are shock absorbers? I hope you might have seen. Or the two spring-like things which you find near the back wheel of a two-wheeler, you call them as shock absorbers. And the same shock absorber will be there for all four-wheelers, three-wheelers, buses, trucks, everything.
Sir, what, sir?
I'm showing you. Have you seen this anything like this?
Yes, sir.
You
Sir,
call
but
this
it is suspension, na, sir.
another technical name for it is suspension. A common word is shock absorber. So these are shock absorbers, spring-like thing. Shock absorber.
Sir, is it used to absorb lightning or to for a spring action, sir?
Lightning is a different thing. It is not used in lightning. It is absorb. It is used to absorb the shocks. Suppose you are going on a bike, or let us say you are going on a bicycle. Most of the bicycles don't have these shock absorbers. Of course, if you go for high-end bicycles, these bicycles nowadays they come with shock absorbers. But let us say you are going riding a basic model of bicycle where there are no shock absorbers. If you come across a speed breaker or if you cross over a pit, then you feel that jerk, you feel that shock.
Yes, sir.
If you go over the same speed breaker with a automobile like this, which has very good suspension system, or a car or a truck bus thing, then you don't feel that shock, you don't feel that jerk.
Yes,
Because
sir,
what
with
happens
spring
is
cycle.
this spring, whenever your wheel goes over this speed breaker, this spring gets compressed. And while it gets compressed, the time during which the shock is transferred to the vehicle increases. Without shock absorber, the jerk is transferred immediately to the vehicle, to the automobile. With shock absorber, because it gets compressed like a string, it takes certain time for the shock or for the jerk to get transferred to the automobile. Because of this increase in time, the effect is decreased, force is decreased. So your ride will be relatively smoother on a vehicle which has very good suspension system or very good shock absorbers.
Sir, off-road bicycles and off-road cars have this, sir.
Oh, yes. Then glass items are packed in
Bubble wrapping, sir.
thermocol sheets or bubble wraps. Reason is the same thing. If you put two glass containers or saucers, cups, something with direct in direct contact with each other, and due to some uh, movement or some shock, they hit against each other, they will break. But if you put a piece of thermocol or a bubble wrap or grass or even a folded newspaper, when these two things collide, they will collide slowly. Time will be more. They'll take more time to come into contact. So if time is more, the force will be reduced and they will be saved from getting damaged. Then suppose you are jumping, let us say this is a wall, and on this side you have a concrete floor, and on this side you have this sand. If you jump on this concrete floor, your feet will feel pain. But if you jump on this sand floor, you will not feel so much pain, relatively. Reason is, when you jump onto this concrete floor, you will come into rest immediately, quickly. But when you jump onto sand, sand will get compressed a bit. So the time in which you come to rest will be increased. As a result, the force acting on your feet will be decreased. All these are different situations where we experience impulse. Okay, force into time, basic formula. Change in momentum is also impulse. mv minus mu, or m into v minus u, or final momentum minus initial momentum, or change in momentum. You can write it in different ways. This is impulse. Momentum, impulse, they are related. Momentum and impulse are related. Change in momentum is nothing but impulse.
Sir,
Yes.
sir, if when we jump into a swimming pool, sir,
Oh.
When we make our body like streamlined, we does not have feel many pain, sir.
Oh,
But when we make our body like just flat, we feel more
the
pain, sir.
greater the area of contact, larger will be the force. If you dive straight, then very small portion of your or very less area is coming into the contact with water. So your pain, actually the pain that you get is because of what you call as viscous force applied by water, viscous force applied by liquid on you. Just like how we have friction between solids, there will be viscous force due to liquids. So that viscous force, it depends on the area of contact. Lesser the area, lesser will be the viscous force. That's why these divers, when they dive, they try to go almost straight, like a arrow into the water, so that they experience a very less force.
It is as same opposite as the pressure, no, sir?
No, it's a force, like how we have air resistance and friction. We have viscous force for liquids.
No, sir. The calculation, if the area is more, the pressure will be less. But here, if the area is more, the pressure is more, no, sir.
That is not okay. You can think, okay, take it like that. Right. 3 laws and impulse. Next. Common forces in mechanics. We are studying mechanics basically. Study of motion of objects, motion of bodies. Considering the cause of motion, which is force. Okay. Force, if you take this force, there are different types of forces in nature. You can categorize force in different ways, like okay, one is as fundamental forces in nature. Fundamental forces. What are these fundamental forces? There are 4. We have identified that fundamentally, on a very broad scale, there are only 4 types of forces that exist in nature. They are gravitational force, second is electromagnetic force, third is
Weak nuclear force and strong nuclear.
nuclear force. All the forces that we see in nature, they can be, they are, say, instance of these, any one of these 4 forces. Gravitational force, it is observed between masses. It acts between masses. Any body that has mass can exert or can experience this gravitational force. This force is responsible for the existence of our solar system. This force is responsible for us being stick to the surface of Earth. Gravitational force. Moon is revolving around Earth because of gravity. Earth is revolving around Sun because of gravity. All the planets are revolving around Sun because of gravity. And this gravitational force, this is a very long range force. This is a very long range force. Long range means the extent up to which gravitational force can act is very, very long. In fact, theoretically, it is infinite. Theoretically, it is infinite. Okay, then this is a very weak force. Gravitational force is a very weak force compared to the other 3 types of forces. Then electromagnetic force is that force which acts between charged particles. Particles. We have studied charge in our earlier classes. So if you have two bodies or two particles um, which have like charges, they'll repel each other, and bodies with opposite charges, they will attract each other. Attraction, repulsion are nothing but forces. So if forces which exist between charged bodies, or we call it as electromagnetic force. And this is a short range force. It can act up to a few millimeters, centimeters, or maximum up to a few meters. And this is a strong force. And weak nuclear force, this force is it is observed in certain special situations, like in case of nuclear reactions. Nuclear reactions, and its extent is, its range is very short. Very short. It adds up to the range of radius of an atom. That's all. And this is a strong force. And strong nuclear force is that force which is responsible for holding the protons in the nucleus. You know, protons are positively charged particles. In nucleus, you have protons and neutrons. Neutrons don't have any charge, so no force due to them. But if you take protons in a nucleus, this is a nucleus, and you have all these protons. All are positively charged particles. All protons are positively charged. When we know like charges repel. So if protons are having positive charge, they should repel each other, and if they repel each other, they should move away from each other, and the nucleus should not exist. But it's not like that. Nucleus is existing and it is stable. That's why we have all the matter. Then how are these protons held together without getting repelled? The force which is responsible for holding the protons together is, we call it as strong nuclear force. So this force acts between protons in the nucleus, and its range is very, very short. It acts only up to the size of nucleus, and this is a very strong force. This is one.
Sir,
Hmm.
sir, once can explain what is weak nuclear force and strong nuclear force?
Weak nuclear force is a force which acts or which comes into action in certain nuclear reactions. Nuclear reactions means inside a nucleus, many strange things will be happening. This nucleus can split into two nuclei, or it can emit some energy. It can emit some particles called alpha particles, beta particles. Many strange and new things will be taking place in the nucleus. So whenever a nucleus undergoes certain reactions like this force will be coming into action. It is a temporary force. It's observed only during nuclear reactions. Strong nuclear force is that force which is responsible for holding the protons together without getting run away because of their like charge.
Weak nuclear force will hold the particles. Yeah?
Strong nuclear force holds the protons inside the nucleus. Weak nuclear force appears during nuclear reactions only.
Nuclear reactions. Yeah?
Yes.
Okay.
This is one classification of force, like fundamental forces. Then we have another classification like contact and non-contact forces. Contact and non-contact forces. As the name themselves say, contact forces are those forces which can act only because of only when the two bodies are in physical contact with each other, like pulling, pushing, friction. If you want to push an object, or if you want to pull an object, you should hold it either directly or indirectly. You by in your hand, or you should tie a rope to it, something. So only when there is physical contact between you and that body, you can apply force on it. You can pull it or push it. We call such forces as contact forces. Forces which can act even without physical contact between two bodies, we call them as non-contact forces. Gravity, there is no physical contact between Earth and Moon. Still, Moon is attracted towards Earth. Non-contact force. Similarly, magnetic force. When you bring two magnets very close to each other, even when there is no contact between them, they will attract or repel each other. It is a non-contact force. This electromagnetic force, it is a non-contact force. It does not require physical contact between bodies. Contact, non-contact forces. Another type is common forces, which we have to study now. There are 4 or 5 types of common forces which we see in our day-to-day life, which we should understand in a technical way. Like tension is there, friction is there, spring force is there, normal reaction is there. We should understand these forces. Okay, we will do that tomorrow.
Sir,
Yes.
so if that string theory is now the string theory,
String
is-
theory, yeah, it is still being investigated. According to string theory, matter, the atoms, electrons, protons, and neutrons, they are further made up of smaller particles called quarks, and these quarks are further made up of smaller particles called strings.
but it is not proved for now, sir.
No, it's still in theoretical proposition stage only. We don't have any evidence of that.
Okay, sir. Thank you, sir.